Okay, so today we're going to be working on using a table of values to graph a linear equation and deriving equation from a line of table of values. We're going to start by making sure that we understand what a coordinate grid looks like. Okay, so a coordinate plane. When you see this, it is also called a coordinate plane. A coordinate plane is formed by two real number lines that intersect at a right angle. We are talking about two real number lines here. What two are those, and what do we call them? Okay. Okay. Okay, what do we call those two number lines? We give them names. We give them the name of axis. You have an x-axis and you have a y-axis. One thing to remember is we are talking about a two-dimensional plane. We are talking about a flat surface. We are not talking about three-dimensional. So right now we're talking about two-dimensional. Yes?
If it was three-dimensional plane,
I believe that is correct. Yes. Okay? So with this coordinate grid is also called a coordinate plane. Okay? We've done this before. You've done a lot of times where you've had to graph on a coordinate grid. So here I have 5 coordinates, and I'm going to have you graph these points. What? So this is quadrant 1, quadrant 2, 3, 4. Quadrant 1 points are always going to be a positive x, a positive y. So when you see coordinate points, if it's positive, positive, you know your point is always going to go in coordinate 1. Coordinate 2 is always a negative x, positive y. Coordinate 3 is always negative x, negative y. Quadrant 4 is always an x and a negative y. It's really important that you recognize this because when you are graphing, you want to make sure you know you're in the right quadrant, and you know that by which one of the data points or which one of the points are negative and which one are positive. And you also need to remember you always do x first. So it's always right to left first, up and down second. Okay? Okay, now what we're going to do is we're going to look at solving expressions and graphing them. Okay? Up here, we have an equation. We have y equals x plus 2. And we need to take that and we need to show on a coordinate grid what y equals x plus 2 would look like. Okay? What is one problem for trying to figure out how to put this on a coordinate grid? What don't we know? We know what y equals, don't we? Yeah. Y equals x plus 2. We don't know what x equals. In order to plot points on a coordinate grid, what do we need to know? We need to know what they both equal. Charlie.
so if there isn't a specific...
What we use to solve this is we're going to use a variation of numbers. Okay? We're going to use variables. Different numbers to represent what they are. So, we know what y equals. We know that y equals x plus 2. In order to figure out the numerical value of y, we need to know what? What x equals. Okay? So what we're going to say is this. You know what? We're going to say, what if x equals 2? What if x equals 4? And what if x equals 5? We're just going to put some varying numbers in there. Okay? And we're going to put our original equation right there. Y equals, yes you should, plus 2. Okay? If you want to, yeah. Actually, this might be a good thing to do in your very first quadrant sheet on here to go along with me. Okay? Basically, because we're not given the value of an x or y, we can decide a value for them. We can give x a value. We can give it a random number. Because no matter what number we put in there, y will equal that expression when you simplify that expression. I'm going to go with 2, 4, and 5. Just going to do random numbers. Now, I've identified what x equals. In this case, I'm saying x equals 2. So all I need to do is substitute my x over here, and I have y equals 2 plus 2. And if y equals 2 plus 2, y equals 4. So my coordinates would be 2, 4, right? Okay? Well, let's say that if x equals 4, well, I would say y equals 4 plus 2, which means y equals 6. So my coordinates would be 4, 6. Okay? I'm going to say x equals 5. So I would say y equals 5 plus 2. 5 plus 2 is 7. So my y equals 7, and my coordinates are now 5 and 7. So I have now determined 3 coordinates that if I plug x's value in, I know what y is, and I have 2, 4, 4, 6, and 5, 7. So let's take our coordinates we got from our graph, and let's plug them into here. So our first one, we said x was what? 2, y was 4, x was, y was 6, x was. Now what we're going to do is we're going to plot those on there. And I should have 2, 4, put a line, 4, and 6, put a line, and I have more that I can fit, 5, and 7. What I have now are points that I can put together. When I connect these points, so I want you all to graph your points on your coordinate grid sheet. So graph your points, get out a straight edge, and I want you to connect your points and see what you end up with. Okay, when you connected your lines, what did you find you got? A straight line. And that's what you should have got. If you are solving it right, you will end up with a perfectly straight line, because what you're saying is if y equals what I put for x in, and I'm always adding 2 to x, you should have a perfectly sloped line. You should have a nice straight line. Okay? Yes? It is. Essentially, this is an in and out table. What you're doing is you're taking it a step further. We're taking what you did as in and out tables. We're applying it to an equation, and now we're graphing it. So that's how we're kind of building on what you've been working on. Sophie. So I'm going to go 2, 4, and I'm going to go 4, 6, and then I'm going to draw a straight line, and with this I can draw a perfectly straight line. I'm going to draw a line from here, right through there, and I'm going to let go. Okay, this one won't work quite well. But what you can then do is any point this line passes through can become a value for x. Are you kidding? Okay, so let's give this one a try. We're going to graph the equation y equals 3x plus 1. So I want you to do on your bottom one, on this one, so we're down here now. Evan, we're down here. Start filling in, start with your table. Now, when you are doing your test, you will not get this table. You will get the equation only. You will have to draw this yourself. So this is one of those things you use to help yourself figure things out. So we're going to put the equation in here so you would know, identify your x, identify your y. Here's your coordinates. Here is the equation you are looking to solve. Okay? I'm going to draw a stick, and I'm going to have you give me a random number for my x coordinates. So, Amaya, give me a number. Huh? Where is she? Sam. Okay, make the x something that fits on here. No, I mean I would, but I can't do 7, so give me something that fits on there. 2.5. Okay. Dylan. 4. Chloe. 3. And Morgan is not here. George. 1. You could also do 0. Okay, so let's go ahead and let's figure these out. So our first one would be y equals 3 times 2.5 plus 1. And now you have extra space, so you may want to do this in extra space. So 2.5 times 3, 15, 7, 7.5, oh, plus 1, 8.5. Well, I have to do my parentheses here because I'm multiplying a number times 3. So I would do 2.5 times 3 because I'm saying x equals 2.5. That equals 7.5. I add my 1. Y equals 8.5. Okay? I want you all to do 4, 3, and 1. In this one, you would have had y equals 4 times 3 plus 1. And what was that? 13. You have to remember to add that 1. This one, you'd have y equals 3 times 3 plus 1 gave us 10. And 1. Y equals 3 times 1 plus 1. So, up here we have the coordinate 2.5, 8.5. Here we have 4, comma 13. 3, comma 10, 1, comma 4. Now I know you can't graph some of these because yours doesn't go far enough. So graphing them, my first one I would go 2.5 and 8.5 right there. Graph as much as you can. Some of these you can graph. Okay, the next one I would do 4 and 13. Okay. Next one, 3 and 10. 3 and 10. And then 1 and 4. You can do the first two. 1 and 4. You can do this one and this one. The first two in the slope you can do. Okay? So once you do your points, you draw your line, and you connect them. Now the key is this. You will find out if you're wrong when what happens. It's not a straight line. That's how you will know you are wrong. Don't connect the dots in a zigzaggy line and say, well, I connected them. That zigzaggy line is a clue, okay, this isn't right. Okay, so you draw a line that goes right through your points. And there it is. Well, I know, but if you did just these two, you should be able to get a pretty good start. Okay? All right, looking at it now, can anybody find one other value for x that would make this equation work? So looking at it, what's another value based on this line that we could put in for x that makes this work? Braden. Well, we would put in 2, right? 2. The value of x could be 2. Any other ones that the value of x could be? Jack. If I extended it out more? Well, it has to be one that this is touching. Remember, we're putting the value in for x. Yes. There. This one you'll notice is a little bit different. Let's look at this equation here. What has to be done before we can graph this equation? What would we have to do before we can graph this equation? So we have y plus 2 equals 3x. Okay, here's what I know. So you need to ask yourself, what is the difference between this equation and this equation? What is the difference? Yes? No. Just this equal. Look at the structure of this equation. What is different about that equation, and that equation? What is the difference? Is that what you were going to say? Yes. You have solved for y in all the other ones, correct? So what is the first thing you are going to have to do for this one? You have to do what? Isolate the variable. And which variable do you want to isolate? Y. And the reason you would choose Y doesn't have a coefficient. Y is all by itself. Because it is. Okay? So your first step, isolate Y. What are you going to do to isolate Y? Subtract 2 from both sides. So I'm going to subtract 2, subtract 2. My new equation is what after I subtract 2 from both sides? Does this look more familiar? Yes, that looks like what? The other equations we did. That is the first step when you get an equation where you have not isolated one of the variables. If there's a variable not isolated, your first step is to isolate one. Choose the one that does not have a coefficient. Choose the one that does not have brackets. Choose the one that's already alone and isolate that one. So on your papers, underneath your table, you should have the equation written where Y is isolated. You're going to solve for Y. Solve for Y. Or isolate Y, or however you want to write it. Cool. This is one reason why we had to learn to do this, yep.